pick up on that. It's a great segue in that, as you know, I mean, great R&D is not linear, and so there's
Yeah.
sometimes your best insights come from experiments that don't go as planned. So I'm just curious, I mean, can you kind of share a moment when failure actually accelerated your innovation pathway?
Yeah. Yeah, that's a great question. And I'm going to go back to my favorite example is I'm in grad school and I worked on, for a guy in beauty, right? But I actually worked on lithium-ion batteries at the time. So this is, way, way back in time. I wouldn't say how old I am. But we're trying to get electrolytes to transport the lithium ion because, of course, you want as fast transport as possible. But one of the challenges is in a polymer, right? The ion is essentially interacting, and when you have the charge, it's moving along. But the charge interactions of the polymer are slowing it down. So essentially, what you want is you want something that can move really fast across there,
Mhm.
right? And so one of the ideas we had was, okay, why don't we actually trap the lithium ion in, there's these compounds called crowns and cryptons. Why don't we trap it into this crown or krypton so you kind of dissociate a little bit? And then now, even though it's slightly bigger, it's not going to be stuck essentially to the polymer matrix and it will be able to move faster. To do this experiment, lithium, crown or krypton, solid, solid, and then you mix it together, you get a solid, and then you dump that into the polymer and whatever, right? Okay, mix the two together, and there was this one particular combination. It's not solid, it's not a white powder. It's like almost, it's glass, almost liquid-like. It's like,
Mhm.
okay, obviously I did something wrong, right? So you do it again, you mix it, evaporate everything off. It's still this soft liquid, and I was like, "What's going on?" And that turned out to be a big deal for my thesis, actually, because actually what was happening is because if you think about what's going on is that lithium ion inside crown or krypton, you would get a solid material most times. But if it had the right size where the ion couldn't actually interact really strongly in the cage,
Mhm.
it was bouncing around, it essentially became glass because the structure, there was not enough ionic force to hold the structure because it was just moving so much. And guess what? You put that into polymer, it's still moving around quite fast, which also helps with speed. So it was a pretty cool thing to learn about because it was like, for a long time, I was like, what the heck is going on here, right? This is just messing up my experiments, right? But it turned out to be a really fruitful part of research. So,
That's fascinating. Thank you.